Thank you very much. Ahoy, my name is Russell Keith-Magee, and I'm here today to show you how you can build a cross-platform GUI application using nothing but Python. First off, who am I? Well, I am from Abuja, otherwise known as Perth, Western Australia. I am a member of the CPython core team and a principal engineer in the open source group at Anaconda. Anaconda pays for me to attend conferences like this one to talk to people like you, so I'd like to thank them for that support. They also support the Python open source ecosystem more broadly by providing direct financial support to organizations like NumFocus and by employing developers to work full-time on open source projects like Jupyter and Number, and the open source project that I founded, BeeWare. For those who haven't come across it before, BeeWare is not a single product or library or tool. It is a collection of open source tools and libraries for creating native user interfaces in Python for desktop, but also for iOS, for Android, for single-page web apps, and for console. Each tool in the BeeWare suite solves one specific part of the overall problem of writing a GUI app in Python and distributing that app to other people on various platforms. Anaconda supports BeeWare to ensure that Python remains a viable programming language on the platforms that people are increasingly using as part of their day-to-day computing life, phones, tablets, and so on. However, it is important to note that BeeWare is not an Anaconda product or anything like that. It is a fully open source project with independent governance and funding. I just happen to be paid by Anaconda to work on it full time. And so, today, we're going to look at the BeeWare suite of tools and how you can use those tools to write and deploy a GUI app for desktop, iOS, and Android, and a couple of other platforms, all from a single, pure Python code base, and then how to access some of the capabilities of those hardware platforms. This is going to involve two pieces of the BeeWare suite. The first is Toga. Toga is BeeWare's cross-platform GUI toolkit. It lets you use a single code base to write a GUI application that can target multiple platforms. And on each of those platforms, what you get is a native user interface. So on macOS, it will look like a macOS app. On iOS, it will look like an iOS app. On Android, it will look like an Android app. And that isn't just cosmetic appearance either. The apps actually are native. Toga is abstracting the native system widgets and capabilities, providing a common Pythonic API to build your apps, but actually implementing those APIs with native widgets. This also means that you inherit all of the native capabilities of those platforms. So, for example, accessibility affordances like screen readers and adaptive font sizes just work out of the box. The second piece of BeeWare we're going to use is Briefcase. Briefcase is a tool for packaging Python applications. It takes your collection of Python code and wraps it up as a standalone user that you can give to an end user with no Python experience at all so that they can install it on their device of choice. And the end user that uses your code will not ever know that they are running Python. In our case, we're going to use Briefcase to prepare an iOS and Android app that could be submitted to those platforms' respective app stores. And so the end user would go to the app store, download the app, pay whatever they want, whatever price you put on it, and it would be on their phone. They would never know they're using Python. Now, while Briefcase obviously pairs very well with Toga, Briefcase is not BeeWare or Toga specific. You can use Briefcase to deploy a Pygame app if you wanted to. Briefcase can't magically make Pygame work with iOS, because Pygame doesn't work with iOS, but to the extent that a GUI library supports any given platform, Toga can, generally speaking, a Briefcase can, generally speaking, support deploying to that platform. So, let's dive right in. Let's write an app and then deploy it across multiple platforms. We'll start with something relatively simple, text inputs, buttons, and dialogues. We'll add more features as we go along. So where do we start? Well, Briefcase has a wizard that you can use to bootstrap a new application from scratch. So we create a new virtual environment, we install Briefcase, pip install Briefcase. With Briefcase installed, we can then run the wizard to start a new project. We run Briefcase new, you'll get presented with a list of questions and explanatory text. You get asked for details like the project name, your name, email address, license details, and your preferred GUI framework. We're going to create an app called PyCon Demo. We're going to use Toga as our GUI example in this case, but there are also templates for other GUI frameworks like PySide and Pursuit by Bear and Pygame. There are third-party toolkits that provide Briefcase plugins as well, or you can select an empty project with no GUI toolkit at all. When you complete the wizard, Briefcase will generate a stub application for you and give you instructions on how to run that project. So let's follow those instructions. We cd PyCon demo, and we run Briefcase dev. Briefcase includes a developer mode, which lets you rapidly iterate on your application and its configuration. When you run Briefcase Dev, Briefcase looks at the project configuration, works out how to run your project in your local virtual environment. The first time you do this, it'll install the dependencies based upon what your template has generated. So it'll install things like the GUI toolkit that you selected, and it will start your application. For what it's worth, Briefcase Dev is not much more than a convenient shorthand for a pip install followed by Python -m PyCon demo with a couple of debug flags and other environment things turned on. Anything Briefcase is doing, you essentially could replicate by hand. Briefcase is just making it a lot simpler so you don't have to remember the long form incantation to set up your environment. And if all you've got is the content that was generated by your wizard, at this point, what you'll see is a working app. It will be an empty window, but it will be a fully functioning native application. So, what has the wizard generated for us? Well, if you look in the PyCon demo folder that's been generated, you'll find all the code for your application, application icons in a variety of formats, and project metadata. You will get the same files regardless which GUI framework you pick. The only difference, if you pick a different GUI framework, is the contents of app.py, done to main.py, and some of the values in pyproject.toml and the readme and license files. The pyproject.toml file will contain the literal answers that you just provided in the wizard, plus some values that can be guessed, like the initial version number. If you've got a Git configuration, it will be able to guess your username and email address. And some additional platform-specific configuration that was implied by the answers that you gave. So if you selected Toga as a GUI toolkit, you'll get the requirements for a Toga application. All of the briefcase options are defined in a tool.briefcase section and subsections of your project file. Some PEP 621 format metadata is on it as well. Briefcase actually predates PEP 621, so we've got a bunch of settings that kind of mirror what PEP 621 is doing. We have a longer term project to kind of migrate towards using just the PEP 621 settings. So that's your project configuration. What about the application itself? Well, the logic for the app is all contained in app.py. At the moment, it's a bare stub. It declares a class called PyConDemo, which is a subclass of toga.app. That app has a startup method. When that startup method is called, when the app starts up, it creates a box. That's Toga's representation of a generic container of content. It creates a main window, sets the content of the main window to be our box, and then shows the main window. The main method for the app just creates an instance of that class. That's all the code we need to generate the empty app window that we just saw previously. So let's replace that startup method with some real code that actually does something. So in our startup method, we're going to define a static text label with the text your name. Toga then lets you set the style of each widget using a subset of CSS called pack. So we tell Toga we want this widget to have a margin around the outside, so no margin on the top and bottom, 5 pixels on the left and right. We then define a text input so we can get some information from the user. Again, we'll give it some style. We'll mark the text input as flexible. Toga's layout, like I said, is based on CSS. It's essentially a subset of CSS3's flexbox. So by marking the text input widget as flexible, it means when the window gets bigger and you drag the corners of the window to be bigger, any additional space will be filled by the text input rather than by the label. You'll also note that we've attached the text input widget as an attribute of self. In this context, startup is a method on the application, so self is the application instance that is running. We assign the input to self so that we can access that widget later. So we've got a mechanism of saying, okay, well now tell me the value of the widget. There are other ways of getting at that content though. That's not the only way that you could retrieve the app later on, or retrieve the widget later on. We then create a box, which is, again, the basic container in Toga. We tell it it's going to have 2 children, the label and the text input, and indicate that it's going to be a row box. So all of its children will be stacked horizontally, right to left, with a margin around each element. Next, we define a button. The button will have a say hello text on it and a margin. And we declare that when the button is pressed, we want to invoke the say hello handler on our application. Now, that's all the widgets that we need for now. So we can define our app's main box again. This time we're going to say the main box is a column box, so all of its children will be stacked vertically. And instead of declaring the children at time of construction, we're just going to add them one by one afterwards. Functionally, it's identical to what we did with the row box, just showing that there are multiple ways to set up your application. So we have a main box that is a vertical, the first child of which is a horizontal box containing a label and a text input. Underneath that horizontal box is a button. At that point, we can pick up where the old code left off. We create a main window, we set the content of the main window to be our main box, and show the main window. One piece of housekeeping left. We said that when the button was pressed, we want to invoke a say hello handler on the app. So we'd better declare that handler. A handler is just a method that you can invoke, or that will be invoked whenever the button does something interesting, in this case, when the button is pressed. So whenever say hello is invoked, the first argument is the widget that generated that event, in our case, the button. There is only one button in this example, so having the widget doesn't really help us here. But if you did have multiple widgets all attached to the same handler, you could use that widget argument to determine which button actually called this press handler. What happens when the button is pressed? Well, we're going to show a dialog to the user. That dialog will ask the name text input for its current value and use that value as the title of the dialog. Now, the astute amongst you will have noticed this is an asynchronous handler. Toga will use any function or coroutine as an event handler, and Toga fully integrates Python's async IO event loop with the native platform event loops that GUI frameworks have. Why would you want to use an asynchronous handler? Well, no matter the GUI framework, no matter the platform, a GUI application basically boils down to a loop. That loop is essentially, while not quit, process events redraw. Now, that is pseudocode, not literal API out of any GUI framework, but honestly, it's not that far from reality of almost every GUI framework I have ever used going back 30 years. Every time you click on a button or type a character or drag the corner of a window to resize it, in the point of view of the GUI framework, that's an event. And the app code will respond to each of those events in turn, causing changes in the state of the app. Those changes in state are then reflected in the appearance of the app the next time it's redrawn. The critical detail: when the app is redrawing, it's not processing events. And when it's processing events, it's not redrawing. If you've ever seen a macOS application throw up a beach ball or a Windows application throw up the little blue swirly, this is what's going on. Your application is spending too long processing events. The operating system has noticed and said, oh, hang on, I haven't redrawn it a bit. This application has locked up. And so it warns you by throwing up the beach ball. So yeah, it indicates there's a problem there. If we go back to our event handler, we want to show the user a dialog, but then we want to wait until the dialog has been acknowledged. If the handler was a synchronous method, while you were waiting for the user to respond to the dialog, the app wouldn't be processing any other events or redrawing. And depending upon the platform, that might even include drawing the dialog itself. By using a coroutine and awaiting the result of the dialog, we can pass control back to the event loop until the user presses OK or cancel or whatever on the dialog, and then the coroutine resumes where it left off, letting the code know, oh, OK, the result of this dialog was yes, OK, continue. All right, so that's all the code we need for a simple GUI app that will show a dialog when the user presses a button. So let's run it. We run briefcase dev again. It'll start the app. This time we'll see an app with a label and text box and a button. The text box is flexible, so it expands to fill the available width. Buttons are flexible by default, so it does as well. We type in a name, we press the button, and you'll get a dialog, and whatever text is in the text input when you press the button gets displayed in the title bar of the app. All right, so we've got an application running in development mode on our laptop. Let's run it as a full app. First step, we need to create our application. To do this, you invoke briefcase create. This will do a bunch of things. First, it will look for the platform you are currently on and get an application template for that platform. So I'm running on macOS, it will use a macOS app template. Second, it obtains a support package. A support package is a version of Python that can be embedded into your app. So whatever your platform, Briefcase will download a support package, unpack that application, or unpack that support package into your application template that was just created. Then Briefcase downloads and installs a stub binary, a literal executable that can be used to start your app. Think of this as a copy of python.exe that has been hard-coded so that the only thing it can do is start your application. It does a couple other things beyond that, but fundamentally that's what it's doing. You need that stub application so that when you start the application and then you look at your task manager or where it appears like on a macOS or a macOS menu, it identifies itself as PyCon demo, not python.exe. Then Briefcase installs your application code, anything declared in the sources section of your project definition. It then installs or downloads and installs your application's requirements. But at this time, it's not installing them in your local virtual environment. It installs them into the application template. We are building an application for distribution, and you can't rely upon your local environment being available for whatever user ends up using your application. The application is effectively an isolated virtual environment of its own that needs to be able to be relocatable to another user's computer. And so it installs all the dependencies into that isolated environment. Then Briefcase installs any application resources like icons, purges any content that isn't needed, and it's done. You've now got a complete application template. Next step is to build the app with Briefcase Build. What happens here varies a little bit from platform to platform. On macOS, it needs to sign the application binary. macOS binaries all need to be signed, so it goes through and does a signing process. On Windows, it needs to write some app metadata. On Linux, it actually needs to compile the stub app because you've got a local copy of glibc. It needs to compile it and make sure it all works. And at that point, there will be a subfolder of your project called a build folder that will contain your application along with any other files created as part of the build process. In this case, it's a macOS app, so you'll see a little macOS grade B icon there. If you were to double click on that icon, the application would start, or you can keep it all console-based and use Briefcase, use Briefcase Run, it will start your application. And what you'll see at that point is a running app. It will be almost identical to what you saw in Briefcase Dev, but with a couple of very subtle differences, because this time it's not a local copy of Python in your Python virtual environment, it is a standalone application. So it will identify itself to the operating system as your app name, not python.exe. It will have an icon that is your app's icon, not Toga's icon, and so on. All right, so that's desktop deployment. What about deploying to mobile platforms? Well, the steps are exactly the same. Just add iOS or Android to all of those commands, and you're done. Briefcase create iOS, Briefcase build iOS, and similarly for Android. iOS builds will only work on macOS because of the underlying tooling requirements, but Android builds will work on macOS, Linux, or Windows. If you run Briefcase run iOS, Briefcase will then ask you, well, where do you want to run this code? And it will look for any simulators that are installed on your system. Provide a list that you can choose from. If you want to shortcut that question, you can pass in an argument later on, -D, iPhone 16, it will use the iPhone 16 emulator. On Android, Android doesn't ship with a collection of pre-built emulators, but it does have a mechanism for creating them, and Briefcase will prompt you to say, oh, okay, well, do you want to use one of your pre-existing ones or create a new emulator? Select create a new emulator, and it will walk you through the process of creating a B phone, which is basically a Pixel 7 with a nice name. Once you've picked your device, your app will start, and what you'll see is a mobile app that has the same layout as your desktop version, but running in an iOS or Android emulator. Type some text, press a button, and you'll get a dialog or a platform-specific dialog. Briefcase can currently only target iOS simulators from the command line. It will manage the process of starting the simulator, launching the app on the simulator, tailing the log so you get to see all the console output of the log as it runs. You can deploy to physical devices, but you need to use Briefcase Open to open the Xcode project that Briefcase has generated. You have to sign up for an Apple developer account, specify your developer credentials, and then run, and then you can have it running on your physical phone. I've got a bunch of apps on my phone that I've deployed that way. On Android, you can target any emulator or attached devices. You do need to do a really weird dance where you've got to go into your settings menu and press a button 7 times and then it puts itself into a mode. But Briefcase will walk you through that process to get your phone set up as a developer device. Briefcase can also target a single-page web app, exactly the same process. Briefcase create web, Briefcase build web, Briefcase run web. Briefcase will generate a bunch of static web content that you could upload to any web server, FTP in a collection of static files. Or Briefcase Run Web will start a local web server, open a browser, point the browser at the server, and you'll see exactly the same application rendered as a single-page web app. Type a name, click the button, and you'll get a dialog. Now, this is a static, single-page web app. All of the application logic is running in the browser. None of this is server-side. All the server is doing is delivering a payload of content to the end user. When you push the button and it goes and says, oh, okay, I need to then go and pop up a dialog, that logic is running in the browser using PyScript to embed a full Python interpreter into your running browser. It's also possible to run this demo in the console as well. So this is a Toga backend that's implemented using textual. It's a little bit messy to set up at present, but it is possible. It is exactly the same user interface, exactly the same GUI. It actually even responds to mouse presses. So you can click with your mouse on the text on the button there, and it will pop up a dialog in your 80 by 25 console. All right, Toga's web and console backends are the backends that need the most work. They're enough to run this demo, but and a little bit more, but they do need a lot more work to be at parity with the desktop and mobile platforms. So if you're looking for an open source project to contribute to, I'm just saying, there's like opportunities. Having validated that our application works, we can now package it for distribution. you can invoke Briefcase package, and Briefcase will do any final packaging necessary to produce a single artifact that you can give to somebody else. What is involved there, again, depends upon the platform. On Windows, it will create an MSI installer, including signing that MSI installer if you want to. On Linux, it will create an RPM or a DEB or a PKG package. On macOS, it will create a DMG, including signing and notarizing the results of that DMG. On macOS, you can also generate just a bare.app, or you can generate a PKG installer as well if you have some post-install steps that you need to run. Now, on Linux, we can also generate flat packs, so you can have the sort of the single app redeployable artifact experience that macOS and Windows users are familiar with. Some other features that are worthy of note. Although I've used the wizard to bootstrap this project, you don't have to use the wizard. You can manually write your pyproject.toml or pyproject.toml briefcase configuration from scratch, just type it all in. Or if you've got an existing project that has a briefcase.toml and a bunch of PEP 621 keys, briefcase convert can be used to add a briefcase configuration to that pre-existing project. If you're on Linux, you can also target different distributions using Docker. If you provide a -- target option with a Docker base image when building and packaging an app, you can use Briefcase Briefcase will use Docker to build a deb package while you're running natively on Fedora, or you can build an Ubuntu 22.04 image while you're running on Ubuntu 24.04. It will even go as far as letting you run the application, because you can run the application inside the Docker container, export the X-display to your local desktop, just to validate that my Fedora app will work even though I'm running Ubuntu locally, or whichever way around it happens to be. Briefcase also allows for a -u option that updates the app before execution, so your development cycle could be just briefcase run -u over and over and over again. Briefcase open, I have mentioned before, it will open your project. If it's a simple project like a macOS app, that's basically just opens your file manager in the folder that contains the generated application. If it's an IDE-based project like it is for iOS, or there's a Visual Studio and an Xcode backend for macOS and Windows as well, Briefcase open will open the IDE on the project that has been generated by Briefcase. And if it's a Docker build, it will open a shell session inside the Docker container that was being used to build the app, which can be useful for sort of diagnosing why something's gone wrong on this alien Unix platform that I'm not familiar with. All right, so we've got a working cross-platform GUI application. Let's add some more features. Well, what are we going to add? Mobile devices have GPS readers, so they're great at displaying maps. So let's add a map and a GPS read to our application. Since we want to add additional features and not just replace the features we already have, we're going to need some way to navigate around our application as well. So let's add a tab widget so we can switch between pages of content in our application. So previously, we created our main box and then set that content of our app's main window. Let's modify that a little bit. So let's create an option container widget that contains 2 pages of content, one labeled dialog, one labeled map. Then we'll set the main window's content to be the container rather than the main box. We'll then use the existing main box content as on the dialog tab. The second tab of content uses a map box, which we'll then need to define. What's in the map box? Well, 2 things. A map set as flexible, so we'll expand to fill the available space, and a button which you can use to update our location. So there'll need to be an event handler when that button is pressed. Put both of those into the map box, and that's our layout done. We've now got a map and a button inside a second tab of our GUI application. We can now define the event handler for when the button is pressed. So whenever the button is pressed, let's get the current location, zoom the map to that location. Location services are governed by platform permissions, so we can't just get the location. We need to make sure that we have permission to get the location first. So before we do, we request permissions from the app's location service. The location service is a hardware feature that Toga has wrapped with a cross-platform API. There's also a camera service. We'd like to add others. There are plenty of pieces of hardware that are common across essentially every iOS and Android device. They've just got slightly different APIs, and we think we can make much nicer APIs than the default platform ones. Asking permissions will check if the user has previously granted permissions to the app. If they have, then that'll be a no-op. If they haven't, a dialog requesting permissions will be displayed. If the user has previously rejected permission, or they reject permission this time, then the request will fail, it'll raise an exception, and then you can handle that by throwing a dialog up or whatever you need to do. But if it succeeds, we can then ask the location for a once-off location ping. That'll return a latitude, longitude, which we can then use to set the center of the map, change the zoom level of the map while we're at it. We can also turn on continuous location tracking if we wanted to, or we could drop map pins. Toga provides APIs for those as well. There's another exception that could be raised here, not implemented. Toga currently has a map view on all desktop and mobile platforms, but it doesn't have a GPS read on Windows. It can get a location on macOS, Linux, iOS, and Android. We'd love to fill that gap. If you know how to do GPS reads on Windows, get in touch. We can point you in the direction. There's two other changes we need to make, this time to the project configuration. We can't just ask for permissions. We need to declare that we might ask for permissions. Briefcase has a cross-platform representation for common permissions like location services, camera access, microphone access, a couple of others. But there is also a mechanism for adding platform-specific permissions if you need to. In this case, we're going to ask for permission to know both the coarse and fine-grained location. Not all platforms differentiate between those two. Briefcase lets you specify both and then interpret them as best it can in the context that it's currently running under. The values provided for the permissions are the text that might be displayed to the user to explain why location access is required. The text I've used here is not a good example, it just fits on the slide. On macOS and iOS, for example, that text will actually be part of the application approval process, and your app may be rejected from the iOS App Store if the text is not sufficiently illuminating in the opinion of the app reviewer who your app lands on the desk of. One last change, on macOS and iOS, map view is available natively, but on Android, we need to add a third-party Android package for OpenStreetMap. This is added as a Gradle dependency. The Android build process will manage downloading the Maven package in much the same way that pip would download a PyPI package. So we need to add the OSM-Droid line to our Android configuration. On Linux, there are also some system dependencies that need to be added. They vary between distributions. I won't dig into it here. There's instructions in the Toga documentation. Now, because we've changed permissions and we've added a binary dependency for Android, we need to regenerate our application. This is a side effect of how Briefcase works. All the files that need to be modified, or the files that need to be modified to add permissions, when you only change the code of your app, or add a dependency, Briefcase can add that dependency or add the new piece of code or copy in the new piece of code. Briefcase's update command will do all that very happily. But when you modify permissions and system dependencies, we need to not just update a file that is specific to Python, we need to get deep into a templated piece of Android configuration code or an Xcode configuration file. And so while we probably could work out how to apply a delta and just change that one line, we have taken like the simple approach here of just saying, okay, no, start from scratch, generate an entire fresh template from scratch. Recreating the app like that might seem like it's a little bit heavyweight, maybe a little bit inconvenient, but it actually shouldn't impact anything in practice. Everything that Briefcase is generating should be considered to be an ephemeral artifact. Okay? Briefcase generates an app from template. That generated content should not be committed to version control. Everything that Briefcase generates or everything that your Briefcase is doing to your app, you should be able to reproduce from scratch from just the pyproject.toml configuration. And then, when you get into CI, for example, to do a production release, you generate the entire application from scratch and then publish that built artifact. All right, so when you do run create, when there's an existing build, you'll be prompted to confirm you want to delete the old project, so you're protected against some mistakes and inadvertent deletion. But when you get around to running the application, we'll get a second tab in our GUI. It contains a map. We press the update location button. You'll get asked for permissions. If we approve permissions, the map will zoom to an updated location. We're on a simulator here, so the behavior is a simulated GPS read, and it will drop you, depending upon the platform, either in the middle of Apple's campus or in the middle of Google's campus, because why not? And there we go. We've got a working GPS read on our application. All right, so far, our app has been built entirely with BeeWare APIs in Toga, or in Toga in particular, but the real power of Python as a language is all the third-party libraries. So how do you add a third-party library to your BeeWare application? Well, if we go back to our pyproject.toml, the application section of our project declares the application's requirements. Previously, we'd specified Toga backends on a platform-by-platform basis, so Toga Coco on macOS, Toga GTK on Linux, and so on. But there is also a common requires block for tools that are needed on every platform. So let's say we're going to add NumPy and Toga Chart as dependencies of our application. NumPy is the NumPy you'll know and love. Toga Chart is a Toga widget, but it's packaged as a completely separate standalone package. It's not part of Toga itself. It's a separate package on PyPI. Toga Chart is a wrapper around matplotlib. It is a native matplotlib rendering backend that will render to a native Toga chart. So when it renders on inside your native application, it's not generating a PNG and showing you an image, it's doing vector art using native platform APIs. Toga chart then obviously has a dependency on matplotlib, so you've got downstream dependencies from just specifying Toga chart. I'm using a bare package name here, but I could also specify, you have a version specifier, platform specifiers, references to a Git URL, a wheel file, a local file system reference. Anything that's essentially legal as a pip argument is legal inside the requires block as well. So we save those changes, we run briefcase dev -r. The extra -r is there because our requirements have changed. So we now need to install NumPy and Toga chart and all the requirements of those packages and so on, and then start the application in dev mode. To run the full packaged app, we could go through the whole create process again, but we've created the application before. We can update the application we've already got. Briefcase update -r, again, to force the update of the dependencies, briefcase build, briefcase run, and we'll end up with a new application running. Or we can shortcut the entire process. Briefcase run -u -r, rerun this application, update the code first, update the requirements as well, and which will also imply the build as well. Add in a platform name, it will do the same thing, but for iOS, for Android, for web, and so on. I won't go through how to use Toga chart today. The Toga specific bits are very similar to what we did with the map widget. You put a big flexible widget to display the chart. There's some other controls to modify how the chart's going to look. The matplotlib and NumPy bits are completely standard NumPy and matplotlib APIs. If you go read those documentation, that's how you use them. But if you were to plug all those things together, you would end up on macOS with something that looked something like that. Histogram generated by NumPy being displayed as a matplotlib histogram chart with some slider widgets. So when the slider widget moves, it changes the parameters, the mean and standard deviation of the histogram. And if we run it on iOS and Android, you'll get exactly the same thing again. So we just added NumPy and Toga chart, which then depends on matplotlib and some other packages. But what about other third-party packages? Well, it depends. If the package you want to use and its dependencies are pure Python, you can just use it. Put it in your requires list, briefcase update -r, and you're done. The only place it will fall down is if your package has if sys.platform equals Windows or code like that in it, in which case you might need to submit a patch to that library to add branches for iOS and Android, because there's obviously something that's going on that is platform specific but can be implemented in Python. Anything with binary modules, that's a little bit more complicated. On desktop, binary wheels will just work. They're pip installed, they're distributed without any difficulty, they'll get added to your application and distributed. On mobile, binary wheels will just work as well. The catch is that most projects don't publish binary wheels for iOS and Android because it's only as of February this year that they've been able to upload them to PyPI. There are a handful of projects that are now publishing binary wheels. Some of them are projects that I maintain. Some of them are where I have submitted patches upstream. For example, Pillow now has official iOS wheels. NumPy hopefully will in the very near future. We're waiting on a dependency to put out a release first. But there are also packages where I've had absolutely no involvement at all, and people are now starting to push those out. BeeWare also maintains an independent pip-compatible repository for some additional common projects. So the reason we're able to install NumPy, even though NumPy doesn't officially have wheels yet, is that BeeWare has actually built the wheels for NumPy and put them into a separate standalone repository that Briefcase will look at if it can't find something on PyPI. They're all unofficial, they work, they're the same source code, they tend to lag a little bit behind those, so the version of NumPy is a little bit older than the current mainline that's available in PyPI. So how do you get a binary wheel for your project? Well, the easiest approach is to use a tool called CI build wheel. It is a tool that is used to build wheels in CI. It is used by a lot of high-profile projects, Pillow, for example, NumPy for another. CI Build Wheel 3 has official support for iOS. Android support has been submitted as a PR, is now in the final stages of review, so we're hopeful that the next release will have Android support as well. Now, despite the name, CI Build Wheel isn't just for use in CI. You can use it locally. So you can check out the NumPy source code, the Pillow source code, run CI Build Wheel, pass in the -- platform equals iOS. There's sometimes some additional arguments that are required, but it will generate and test fully compliant iOS wheels generating straight out of CI Build Wheel. So you can locally go and run that code or run CI Build Wheel over a checkout of a library, get your own local wheels, and then use those wheels as dependencies in your requires list in Briefcase. Better still, take what you've done, submit it upstream as a patch, and then encourage your upstream projects to produce iOS and Android wheels as well. The biggest issue you're going to hit will be porting, in the process of porting, is if the package has non-Python dependencies. For example, Pillow depends on libpng and FreeType and a whole bunch of other libraries. Those libraries also need to be compiled for iOS and Android, and quite often those projects won't have iOS compilation instructions, so you need to work out how to make those libraries compile and then provide them and put them in an environment and so on and so on. It's doable, but if you're not familiar with configure and CMake and Meson and things like that, it might be a little bit complicated. But it is learnable, it is a doable thing. So, a quick recap over what we've done in the last 25, 30 minutes. We have created a new application, we've run that application in developer mode, allowing us to rapidly iterate on the development of our application. We've added some basic input widgets like buttons and text inputs. We've displayed results in dialogues. We've added tab-based navigation between panels of content. We've added a map. We've integrated our phone's geolocation services to control display of that map, including requesting permissions required by geolocation services. We've added a matplotlib chart based upon NumPy data to our app, two capabilities that are implemented by third-party libraries, and all of that has been done entirely in Python, using Python tooling and configuration files to produce an application that is completely native and entirely self-contained. I am a Python developer, but the apps that I've developed could be uploaded to an app store or distributed on a website, and the only instructions the end user would need would be download and click to start. The resulting application would be indistinguishable from an app built in Swift on iOS, Kotlin on Android, or C# on Windows. And yes, there are BeeWare apps in both the iOS and Android app stores. So, that's what we've done, but how? Surprisingly, it's actually not that difficult. Toga is based on a 3-layer architecture. The top layer, the interface, is the published API. That's the thing we document, that's the thing we encourage you as an end user to use. There is a single PyPI package for that called Toga Core. The interface then talks to a second standardized API called the implementation. There's an implementation for each platform, Toga Cocoa, Toga iOS, Toga Android. And then there's the native layer. Those are the actual native platform system APIs. As an example of how this works, take the map widget as an example. There is an interface layer, map view. That specifies that an end user can set a property named location or zoom. When you do that, the interface's value setter calls the implementation over a setLocation API. How's that implemented? Well, on iOS, there is a map view widget that constructs an mkMapView instance, the iOS representation of a map. When you call setLocation, it uses a Python representation of an iOS mkMapView instance, calls setRegion on that instance, converting the platform provided location and zoom level into a region, which is a latitude-longitude rectangle that the map will then display. On Android, exactly the same layered structure, but instead it connects to an OSM Droid map view, and it gets the OSM map view's controller and tells it to animate to a new geopoint. All right, but how does the implementation talk to the native APIs? Well, on each platform, Toga uses a language bridge to invoke native platform APIs. It is a different bridge on every platform, but those libraries allow native Objective-C, C#, Java, whatever language the platforms are using, to be invoked as if they are Python classes. Why do I tell you all this? Well, first, with a very small number of exceptions, if a native API exists for something, you can almost certainly invoke that API from Python. So if iOS provides a native API for Siri integration, you can call that API. It will only work on iOS and possibly macOS, but it will work. You can call that API if you want to. All Toga is a collection of calls to native APIs to create buttons and sliders and labels. The same rules apply to you and anything you may want to do with native APIs. Secondly, if an existing Toga widget is close to what you want but not quite, if there is a native capability that will get you the rest of the way, you can invoke that. There is a semi-official API standard. If you go to a widget.impl.native on any Toga widget, you will get a direct handle to the native object that is implementing the thing that you've got. So if you are on macOS, on a button.impl.native will give you the native NS button that is implementing the button. So you can then call any native API to tweak or modify the behavior of a specific widget. Lastly, all this means contributing to Toga, or Briefcase for that matter, probably isn't as hard as you think it is. If you do need to get comfortable with reading API documentation samples in a different language, but Java and Objective-C documentation isn't that hard to read. You're really just looking for the nouns and maybe a guide of what order do you need to call those nouns. So that you know what method names you need to invoke, and then there's a little bit of, oh, okay, this is how they put arguments in Objective-C, which is a little bit weird, but this is how it maps to Python. It's a learnable skill, and it really doesn't take that much effort to learn the skill. Okay, so what does the future hold for BeeWare? Well, my co-worker Malcolm and I are currently working on finishing up the tools for iOS and Android. We're hoping by the end of the year that will be all done and dusted, and a sort of small smattering of projects will have official iOS wheels, at which point the community, it's up to you to help port those packages to iOS and Android. Longer term, there are still widgets we want to add to Toga. Mobile's missing some key behaviors. We need to put those in. We're hoping to automate more about the app publication process, and endlessly, we're always looking for new platforms, new packaging formats. So that's cross-platform GUI development with BeeWare. If you do nothing else, I would recommend going through the BeeWare tutorial, tutorial.beeware.org. It gives you a complete walkthrough of most of the stuff that I've been speaking about today and some more. Briefcase has plenty of configuration options and details that I haven't gone through. If you want to know more, briefcase.beeware.org. Toga has documentation as well, toga.beeware.org. There's also Toga's examples repository on GitHub, has a whole bunch of examples of running apps. If you like what you've seen here and you'd like to support BeeWare as a project, you can join the project as a financial member. You can also back me on GitHub sponsors. Or if working kind's more your thing, I will be here till about midday Sunday at the sprints. We are very keen to introduce people to be contributors, and we have shiny little challenge coins for people who get commits. We will find a thing that you can work on. I guarantee we can find something no matter your level of experience. Thank you all very much.
Thank you, Russell, for the amazing talk. Now we will have 5 minutes for Q&A. Please, we have a microphone right there, so please stand up and ask questions.
Thanks for a great presentation. I have a question about how much lightweight is the actual output. Can happen that even Hello World example can produce a 50 megabytes of APK package for Android?
Okay, so you're talking about the size of the final application? Okay, by default, out of the box, an Android application ends up being about 25 megabytes, I think. You can strip that down if you get aggressive. Like that, by default, it gives you all of Python. All of Python contains a lot of stuff you probably don't need. So there are mechanisms in Briefcase to say, okay, I know that Python comes with a bzip2 implementation. I don't need bzip2, delete that out. We're hoping to make that a little bit easier. I think we've previously gotten down to about 8 megabytes as a final packaged implementation. But yeah, so you can strip it down. At the other end, Android in particular has a 512 megabyte cap on how much data you can put into a bundle. So dropping an entire large language model can be a problem. macOS has a 2 gigabyte limit. I think Mac or Windows has got a similar kind of limit. So you need to play, if you want to do things with very big data, you often have to package an application and then download the data separately, but that's just sort of good user experience anyway, so yeah.
Thanks. And is it documented the way how can I strip these Python features?
Yes, the stripping is documented. There's a setting which I'm going to blank because I'm standing on a stage, but I can. It is in the documentation as to how to use it.
Yeah, great. Thanks.
Yeah.
Assuming somebody builds a successful application and they try to monetize it, any licensing concerns or?
It's all BSD 3-clause licensed. There is absolutely nothing that would prevent you from moving it on, selling it, adding a price tag to it, no constraints whatsoever.
Good, so just contributing back then?
Yeah, I certainly wouldn't object if someone was to contribute to that, but no requirement to.
Hi, can you write BeeWare code and debug BeeWare code in your favorite editor like PyCharm or VS Code?
Sorry, BeeWare itself has absolutely no, doesn't care what you do. It's Python code, edit it however you want. Debugging is a little bit more complicated because you're now running code on a separate device that's over here, and so setting up that debugging session can be a little bit complicated. We do actually have a pull request in flight of someone who has worked out how to get both PyCharm and Visual Studio Code to launch the native VS Studio debugger inside an iOS and Android application. So it's not there yet, but I'm hopeful in a order months, maybe, it will be possible.
Okay, looks like there are no more questions incoming, in which case, thank you for the talk, and please give a standing ovation to Russell.
Thank you very much.